All right, this next topic is pretty technical, but I think it's important to understand if you really want to come to terms with the image size command here inside Photoshop. It's all about methods of interpolation, which is how Photoshop takes the existing pixels inside of an image and decides to rewrite them when either upsampling or downsampling. And to give you an idea of what I'm talking about, I'll go up to the image menu and choose the image size command. Now, whenever the resample checkbox is turned on, you have access to this pop-up menu, and these are the interpolation options right here. By default, it's set to automatic, but you can override that default setting by applying any of these other 6 options. And to give you a sense for how they work, I'll go ahead and click the cancel button, and then I'll switch over to this grid of squares right here. Now, we're seeing the grid at the 250% zoom ratio, just so you can get a sense of how things started off. Then I took this pattern and downsampled it to 72% using each one of the 6 interpolation settings in order to produce this diagram here. And now I'll just go ahead and zoom into this lower left corner. Now, the most basic setting is nearest neighbor. All it does when you're downsampling is either keep a pixel or throw it away. And as a result, as you can see here, some of these rows are quite tall, and others, like this row directly below it, are quite short. So we end up with this uneven effect. Now, between you and me, I never use nearest neighbor when downsampling. However, it can be very useful when upsampling, and in fact, I use the setting in order to increase the size of all of these test images right here, so I wasn't introducing any averaged pixels. All right, the next setting is bilinear, and it's a simple averaging function. So as you can see here, we have this middling gray line that's caught between the dark gray square and the light gray square. So it's just averaging the neighboring pixels and nothing more. Next, we have the 3 bicubic settings right here: standard bicubic, bicubic smoother, and bicubic sharper. Now, bicubic interpolation is much more complicated. It uses a series of derivatives that you don't need to know about. But what it ends up doing is sharpening the transitions between the pixels. And as a result, we get these halos. I'm going to go ahead and zoom in here so you can better see what I'm talking about. Notice around the dark squares, we have these dark halos, these dark edges right there. And around the light squares, we have these lighter halos. Most obvious in this square right there. So it's going to vary from square to square, of course, because I downsampled to an uneven amount, 72%. But we're always seeing dark halos on the dark stuff and light halos around the light stuff. Now, if you don't like those halos and you want to tamp them down a little bit, then you can switch to bicubic smoother, which basically splits the difference between bicubic and the straight averaging associated with bilinear. If bicubic isn't giving you enough sharpness, then you can switch over to this guy, bicubic sharper, which gives you these obvious halos right there, the dark halos around the dark squares and the bright halos around the light ones. And as a result, you get sharp, tacky details out of your downsampled images, which is why this is the same as the automatic setting when you're downsampling images inside Photoshop. And then finally, we have the newest of the interpolation settings, which is preserve details. And as you can see here, it delivers sharp edges as well when downsampling. In fact, my tests have demonstrated almost no difference between bicubic sharper and preserve details, once again, when downsampling images inside Photoshop. All right, now let's take a look at upsampling. I'm going to start with this smaller checker grid. Again, we're seeing it the 250% zoom ratio, just so we're comparing apples to apples. And now let's go ahead and switch over to the upsampling diagram. And notice that I went ahead and upsampled each one of these checkerboards to 576%, which just happens to work out well for this image. All right, here's nearest neighbor. And although we do have a little bit of variation between the heights of the rows and the width of the columns as a result of upsampling to this unusual amount, everything is more or less uniform. If I wanted to make sure everything was exactly uniform, as when, for example, upsampling a screenshot, then I would want to make sure to set my percentage value to a multiple of 100%. So 100%, 200%, 300%, and so on. Next, we have bilinear, and as you can see here, it just creates sort of soft transitions between the squares. So again, all Photoshop's doing in this case is averaging pixels. All right, now let's move over to the bicubic functions. We've got standard bicubic, which creates dark halos around the dark squares and bright halos around the light ones. And the result is a slightly sharper image than bilinear. If it's too sharp, then you can switch to bicubic smoother right here. And notice that we do have the halos, we still have them, but we also have some sort of blurry transitions. If bicubic isn't sharp enough, then you can switch to bicubic sharper. And as you can see here, we have these very obvious halos now. And then finally, we have preserved details, which creates even chunkier halos still. But it also introduces a little shape analysis. In other words, it's better at representing circles and diagonal lines and other edges that don't naturally lend themselves to square pixels, which is why it's the same as the automatic setting when upsampling inside Photoshop. All right, so there you have it, all the technical details associated with the 6 interpolation options available to us inside Photoshop. In the next movie, I'll show you how to make practical use of these various interpolation settings when downsampling a photographic image.